All right, so hi everybody, thanks for coming. I am Adam Spires. I'm a software engineer / architect for SUSE, and I'm going to give you a quick introduction to OpenStack's Self-Healing SIG. So here we go. I'm going to just very quickly explain the concept of a SIG, just in case anyone isn't aware of that. I'll talk about the concept of self-healing. I'll give you a very quick list of all the OpenStack projects that are relevant to self-healing. I'll talk about some challenges that we face in the OpenStack community, and then talk about what we're doing to address those challenges. And then finally, I will invite you to get involved. So SIG stands for Special Interest Group. I'm sure you already knew that. And they're a fairly new thing in OpenStack. This is the link to the portal that explains exactly what they are and how they work. And it's a bit like a working group. We had working groups before, but I think there's a bit less pressure with SIGs. That there's not the expectation that when you join you have to commit to actually doing some work. You're just invited to come along if you're interested and you just want to listen or contribute your own thoughts without necessarily initially committing to stuff. So there's a lot of interesting SIGs appearing at the moment. For example, the Kubernetes one, the upgrade one is I think the most recent, and of course the self-healing one, which I'm going to talk about right now. So what is self-healing and what's it trying to solve? Well, who has ever said this or thought this about OpenStack? No one, right? OpenStack's awesome, it's great, but it's super complicated and things go wrong, hardware problems, software problems, and so on. But this SIG is really trying to address this and get to a point where this utopian dream is achieved. So what is self-healing and how does it help us get there? It's not just HA. I kind of see it as a superset of HA. So HA is part of self-healing, but then it extends into other areas. Typically when you say HA, people think about like a cluster manager like Pacemaker or a load balancer like HA Proxy and that kind of thing. And there's lots of traditional connotations around that. But self-healing goes beyond that. So essentially, it always involves some automatic detection of states that might be suboptimal. So it might be a hard failure where there's like literally a hardware failure or like a software bug that causes a crash. Or it might be a soft failure where things are still running okay, but they're not running as perfectly as you might want them to. So like if resources are being used more than gives you the acceptable performance. So traditionally with HA, it's more of a reactive approach, but with self-healing we can be proactive as well. So if we can spot that something is becoming gradually more suboptimal, then we can try and take action and fix that before things go really badly wrong. It generally needs to be intelligent and aware of the context of everything that's going on, so it can make intelligent decisions about what remediation to take. And then, of course, we need the automated action. Otherwise, it wouldn't be self-healing. It would just be healing with people involved. And so that can address issues of reliability, availability, or performance. So here's a quick example. Proactive healing of a soft fault. And so the idea here is the classic noisy neighbor scenario where you might have one guest that's doing a lot of network traffic, and it might be kind of stealing all the network throughput that compute node is capable of and impacting other workloads on the same host. So we can address that by monitoring the network traffic utilization on the data plane on the compute hosts, and then if it exceeds a certain threshold, then we can migrate VMs and offload that network traffic onto other hosts so that we've avoided a problem before it gets serious. So a similar use case, but it's reactive rather than proactive, and it's a hard fault. So instead of the network traffic being exceeded, you could actually have a network interface fail, like a hard failure. And in that case, we want the guest workloads to be automatically recovered. So again, we're monitoring the state of the network interface, and if something goes wrong, then we can migrate the VMs to the other host if they're still alive and we have enough network connectivity on the other, because you typically have multiple network interfaces, so you might be able to migrate the VMs away, or you might just have to do a resurrection from scratch on the other host. And by the way, this use case is already implemented and demonstrated in both this and the last summit, and there's the link, and these slides will be available online. They already are, so you can follow these links if you want. So we have a whole bunch of OpenStack projects that help with self-healing already. I'll just rattle through them very quickly. So we have Manaska for monitoring. I couldn't find a better logo for Air, for the mascot, but that's alarming. Congress for policy, Vitrage for root cause analysis, Mistral for workflow. I don't think Masakari for Compute HA has a logo yet. Freezer for backup and restore, and the Freezer DR has an alternative take on Compute HA. Senlin for cluster resource management, Heat for orchestration, and then of course all this stuff needs to be, like when you tie all these together in various ways, you need to make sure that they all work, so QA is obviously relevant there. And then finally we have a really interesting project which is a bit different to all the others because it focuses less on failures and more on optimization, and that's Watcher. So if we've got all those great projects already, why do we need the self-healing SIG? And well, early on we looked at all the integration points between these and we tried to draw a diagram and try and figure out how they would all fit together, and yeah, it's not very simple really. So the challenges we face, there's lots of integration points, very little documentation on how to tie them all together, even though each project may have great documentation of its own. And in short, it's really hard for operators to make sense of how they can really harness the power of all these great projects that exist. And then on the development side, there's no coherent vision for how development should be coordinated across these groups to achieve the use cases that operators want. So I thought we could do better than that, and that's where the idea for the SIG was born. So the status update is quickly that we formed officially after Sydney, and that blue words there is links to a blog post that I made about how it came to be. We set up a wiki page that is the one-stop shop portal, giving you all the information that you need to know about self-healing. Everything is linked from there. We have a storyboard project which is tracking all the work. I probably need to update that, but I think it's reasonably up to date. And yeah, we started to visualize the integration points, like the diagram that you saw there, for example, and one other. And more recently, we have compiled a list of contact info for the various stakeholders in the different projects, which means that if we need to collaborate with a project on a particular self-healing use case, that we can guarantee we always have some contact point of someone who's agreed to be available. So it's not an exclusive thing, but it just ensures that we can quickly communicate with a particular project if we need to, and it makes that easier. We have been talking to the API SIG and the people behind the health check API initiative, and there's a spec for that which is linked. There's discussions on automated testing, and OPNFV have done a lot of really great stuff on that. So it makes sense to collaborate with them and reuse some of their work. We've talked about various use cases, but honestly, we're in the fairly early stages of the SIG so far. It's not been going long, so there's hopefully lots more good stuff to come. So one of the next things that, in fact, I want to do probably today before the session tomorrow is to populate the repository that we have set up with templates for use cases and specs to encourage people to then submit use cases and specs to document some of the ideas people have. Yep, and so we want to collect those use cases and specs and make it clear to everyone what we're working on. And like I mentioned, we have this session tomorrow, which a discussion, birds of a feather discussion session, and we'd love as many people to come to that as possible and just, you know, hit us with all your ideas and thoughts and things that you would like to see the SIG achieve. So that's tomorrow afternoon in room 217. Additionally, if you want to get involved, you can please join the IRC channel on IRC and subscribe to the OpenStack SIG's mailing list and take a look at our storyboard project. And that's it. So yeah, thank you.